Okay, Assalamualaikum. So we are going to discuss the example under 2.3.1, the independent sample. Okay, so it is a confident interval of the difference between two population mean. So the parameter here is a mu. I forgot to mention before this. Okay, but I hope that you know lah. Okay, when we said population means, then the parameter that we use in this confident interval is mu1 and mu2 lah. Okay, so when we have a question like this, the first step before we jump to the solution is to extract, okay, all the significant information so that when we do the solution, it will be easy lah, because we already know what kind of information that we have. Okay, then choosing the formula will be easy. Okay, so we have two chemical companies, company A and company B. So two different company, so two different populations. So we have independent sample. Okay. Supply a raw material where the most important element in this material is the concentration. The standard deviation of concentration produced by both companies are known as 5.81 and 4.70 respectively. Okay, so so what do we have here? The standard deviation of concentration. Okay, so means that the variable in this question is a concentration. Okay, because we do calculate something from the concentration. So concentration is a variable. Okay, because any value that we calculate must be coming from the data. So your data is a variable. Okay. Known. So the keyword here, known. Okay, when we have word known here, means that the standard deviation here, it is sigma. Okay, so 5.81, it is your sigma A. Okay, because here it mentioned company A first. Okay, and here it mentioned both companies, so it is a company A and company B. So 5.81, it is a sigma A, and 4.70, it is your sigma B. The mean of concentration in a random sample of the 10 batches produced by company A is a 19.25 grams per liter, while for the company B, the mean of the concentration in a random sample 15 batches is 87.54 grams per liter. Okay, so the mean, and then we have sample of 10. So 10 here, it is your sample size. So N for the company A. Okay, so this mean was calculated from the sample. Okay, so means that 19.25, it is your X bar for the A. Okay, so 15 here, it is a N for the company B, and 87.54, it is a S bar for the B. Okay, so consider the random variable concentration is a normally distributed. So why we have this statement? Okay, in order for us to use the formula that we discussed before, your data must be normal distribution. Okay, so we just assume that the data here is a normal. Okay, but if you have your own raw data, okay, you have your own, you conduct your research, so you collect your data, the first thing that we check is a distribution lah, whether it is a normal or not. Okay, if a normal, then you can use everything from here, the formula from here. Okay, if the data is not normal, then we have to go to the non-parametric. Okay, so construct a 96% confidence interval for the difference of the population means of the concentration produced by both companies. Give an interpretation of the parameter estimate. Okay. So here we have 96% confidence level means that alpha 0.04. Okay, another keyword here to show that we have independent sample. You have this, the difference of the population mean. Okay, when you have difference of population mean, it is a independent sample. Okay, when we have dependent sample, it will be confidence interval for mean difference. So we mentioned mean first and then different. For the independent sample, different first and then mean. Okay, of the concentration produced by both companies. Okay, so this question, general question. General means that you can determine by your own which one is a first population, which one is a second population. Okay, so here you can do S bar A minus S bar B, or you can do S bar of the B minus S bar A. Okay, because the question is not specific which one first. If the question first specific, for example, of the concentration produced by company A and company B, so it is compulsory to do S bar A minus S bar B. Okay, if you do B and A, then it will be penalty lah. So give an interpretation for the parameter estimate means that you have to interpret your confidence interval. Okay, let's see the solution. Okay, so because of we have the sigma here, okay, then sorry. Okay, so when we do the solution of, okay, the first step is to extract the information. So we already extract the information here, okay, just now. Okay, and then choose the formula based on the information that you extract here. Okay, so because of we have sigma, then sigma is known. So sigma A, sigma B are known. So use the first formula. Okay, refer back to the formula that we discussed just now. Okay, so here we do the A minus B. So you will have S bar A minus S bar B. Okay, so find the value of the Z here. Okay, so 96% alpha 0.04 divided by 2, then you will have 2.0537. Okay, so make sure you know how to find this value. Okay, so it is on page 36 of your statistical table. Okay, and then you do the calculation here. Okay, then you will get this confidence interval. Okay, so confidence interval for mean, it is okay to have negative. Okay, confidence interval because we calculate for the difference. Okay, but when we have negative confidence interval, doesn't matter. Let's say that we have, so here we have lower boundary as a negative. Sometimes we have both are negative. Okay, so when we interpret, it will be quite different. Okay, so it will be like we are 96% confident that the difference of the population mean for the concentration produced by both company is between. So we do not state the negative here. Okay, so 1.8120, the lower boundary here, grams per liter more by company B. So we mention B first. Okay, because here it is, so here is a minus B. So lower boundary more by the second population, which is company B. to 7.2320 grams per liter more by company A compared to each other respectively. So quite longer lah from if we have the positive confidence interval. Okay, if both positive, how do we interpret similar as what we did for the single population mean? Okay, so the second example here. Okay, so biotechnology company produce therapeutic drugs which concentration is normally distributed. Two new methods, okay, of producing this drug have been proposed, and the method that produce more drug will be chosen by management. So the company choose a sample of size 15 for each method and obtain the following data in grams per liter. Okay, so the 15 here, it is an N. So we have N equal to 15 for the both method X, method Y. So different method, so it is an independent sample. And then from this sample, okay, we obtain the following data. So means that these data are statistic. So you have sample mean, you have sample standard deviation. Okay, so by assuming the population variance for both methods are equal, so what we have here is a sigma square X equal to the sigma square Y. Okay, that's what we mean here. That's how we transform into mathematical notation. Construct a 99% confidence interval on the difference between means of the concentration by method Y and method X. So interpret the answer resulted. Okay, we go to the solution. Okay, so we have the sample mean, sample standard deviation. So means that there is no sigma. So sigma is unknown. Okay, and then we need the second condition, the equality of the population variance. We need whether sigma, we have equal sigma or unequal sigma. So here we have equal sigma. So we go to the formula of the equal population variances. And then the N, which is 15 less than 30. Okay, so we have formula with the SP. So refer to the formula. Okay, you just follow that formula what to calculate. Okay, so here, okay, so we have mentioned here by method Y and method X. Okay, by method Y and method X, so it is compulsory to do Y minus X. Okay, that's why here we have X bar Y minus X bar X. Okay, so find your T value in your statistical table, then we get this confidence interval. So both positive, then how we interpret will be similar as what we discussed for the single population mean. Okay, hope that you understand. Okay, so in this subtopic also we have the one-sided lower bound and one-sided upper bound, similar as what we discussed for the single population mean. Okay, what do we modify here? Just the alpha. Okay, so when we calculate for the one-sided, alpha no need to divide by 2. Okay, the concept here similar to the one population mean. Okay. Okay, I think, okay, that's it for the example. Okay. Oh, sorry. Okay. So please do the exercise 2.3.1. Okay, number one and number two, and after this do it first and then you will discuss.